I want you to imagine that you're holding a handful of pennies and dimes. Not many, less than $1. Go ahead and count up how much money you have. Okay? Got a total? Okay, great. Now I would like you to subtract the number of coins in your hand from your total. Okay. Now, if you did the math right, you should have a 2-digit answer. And the last thing I'd like you to do is go ahead and take those 2 digits and add them together. You should be down to just one number now. And if my mind reading ability is correct, you're thinking of the number 9. So, how did I know that? You could have picked any group of pennies and dimes you wanted, right? There's no way that I could have known how much money was in your hand. There's also no way I could have known how many coins were in your hand. And yet, after the subtraction, I did know something about your handful of change. I knew that your 2-digit answer was a multiple of 9. Now you may be wondering, who cares? What's so significant about multiples of 9? Well, let's take a look. Let's look at the first example here. 23 cents, right? Minus the number of coins. Well, let's think about it. If I've got 23 cents made up of pennies and dimes, well then I must have 2 dimes, 20 cents, and 3 pennies. You agree? That gives me a total of 5 coins. I subtract the coins, I get an answer of 18. How about 51 cents? That would be 5 dimes and 1 penny. A total of 6 coins. I subtract, I get an answer of 45. 73 cents. That would be 7 dimes and 3 pennies. That would be a total of 10 coins. I subtract, I get an answer of 63. Take a look at these 3 numbers. Do they look familiar? They are all multiples of 9. Okay? They have to be. And the reason I can say they have to be is because there's an interesting case that exists with the number 9, and you can think of 9 as a magical number, and you'll see why in a second. Numbers, any number that you choose, if you add up the digits in that number, okay, like 7 and 3, if you add those digits together and you subtract, you will always get a multiple of 9, okay? Works every time. I'm not going to go into the mathematical explanation for exactly why it works, but it has to do with something called a digital root. And if you're really curious, you can get on the internet and research it a little bit. But for now, just take my word for it. Okay? Any numbers, like a 7 and 3, or 5 and 1, or 2 and 3, right? If you add the digits together and then subtract, you're going to get a multiple of 9. 45 is a multiple of 9, 9 times 5. 18, of course, is a multiple of 9, 9 times 2. 63, of course, not 9 times 7. Okay? Now, if you've been paying attention, you might be thinking, wait a minute, I didn't actually add the coins together, right? All I did was count how many coins I had. Well, that's what makes this version of this trick so clever. You didn't actually add these 2 digits together, right? You just counted up how many coins you had. But as you can see, there's no difference between the two, right? Whether you add 7 and 3 together, or you count how many coins are in your hand, you're still going to get the same total, in this case, of 10. Because like we said, you're going to have 7 dimes and 3 pennies. 7 and 3 is 10, okay? So there's lots of different versions of this trick, but this one is particularly clever and deceptive because of the fact that you're not actually telling the participant to add the digits together, okay? All you're asking them to do is to count the coins in their hand. And it's the same as adding them together. Can you see why? Well, it has to do with the types of coins that we allowed you to imagine are in your hand, right? I didn't say coins, I didn't say quarters and nickels, right? I gave you specific examples, right? Pennies and dimes only, okay? Well, look at what happens if you're only allowed to select pennies and dimes. Well, the dimes are the tens place, right? Here we have 5 dimes, that's 50 cents. And the pennies make up the ones place, okay? So, you'll always know exactly how many coins you have simply by adding those two digits together, okay? And that's pretty much it. That is the handful of pennies and dimes. I performed it for you by having you add these two digits together to get an answer of 9. And if you're familiar with the number 9, 9 has all these magical qualities, like I said, one of which is that the sum, or the total, of the digits in a multiple of 9 add up to 9. As you can see from this example, 1 plus 8 would give me 9. 4 plus 5 would give me 9. 6 plus 3 would give me 9. So it didn't matter how much money was in your hand, right? It didn't matter how many pennies or how many dimes you thought you had. Once you've done that subtraction, you would get a multiple of 9. And by adding those two digits together, you get, ta-da, the number 9. And it works every time. And that's pretty much it. I hope that was interesting and helpful. And this is a great way of performing this. I have another video that takes advantage of this same idea of the properties of the number 9. It's called the missing digit trick. And if you're interested in this and this idea that multiples of 9 always add up to 9, or multiples of 9 add up to a multiple of 9, be sure to check out that missing digit trick video that I have, and I'll put a link in the description for you. Okay? Any questions? Go ahead and just leave a comment. Thanks.